Hello students, and this video will prove that e is not a rational number. What we do is we recall that e is defined by this relationship, the sum n goes from 0 to infinity of 1 over n factorial. And so what I'd like to do is I'd like to estimate the difference between e and its nth partial sum. So let's let e sub n be the sum j goes from 0 up to n of 1 over j factorial. And then we can estimate the difference of e and en. So e minus en is going to be, well, it's going to start at n plus 1 factorial. So I have a 1 over n plus 1 factorial plus 1 over n plus 2 factorial, and so on forever. I'm going to pull out a 1 over n factorial, and then I'll be left with a 1 over n plus 1 plus 1 over n plus 1 times n plus 2, and so on forever. Now I claim that what this is less than is I can leave this n plus 1 here, but every other term like this n plus 2 or this n plus 3 or this n plus 4, I'll replace every n plus 2, n plus 3, n plus 4, n plus 5. I'll make this bigger by replacing those with n plus 1, making the denominator smaller. So this is going to be strictly less than 1 over n factorial, and then I'm going to have the sum j goes from 1 to infinity of 1 over n plus 1 to the power j. And that's just an infinite geometric progression, so this is equal to 1 over n factorial, and then 1 over n plus 1 over 1 minus 1 over n plus 1. And so we see that if we multiply both the top and the bottom by n plus 1, what we'll get is we'll get a 1 on top and then an n on the bottom. So this is exactly equal to 1 over n factorial times n. So that's the difference of en and its nth partial sum. Now, I'm going to prove that e is irrational by contradiction. So let's suppose that e is p over q, a rational number. Now we know that e is between 2 and 3, so e cannot be an integer. We know that for a fact, so e is not an integer, which is good. And so then what we'll do is we'll say, then e minus e sub q, the qth partial sum, let's estimate this thing over here, will be the absolute value of p over q minus eq, right, which would be 1 plus all the way down to 1 over q factorial. And that's less than 1 over q factorial times q. And so now the objective is to take this, this absolute value inequality over here and multiply it by q factorial. So if we multiply this expression, this inequality by q factorial, what will we get? We'll get p times q minus 1 factorial minus what? Minus q factorial times 1 plus 1 over 2 factorial plus 1 over q factorial is less than 1 over q. And since we know that since e is not an integer, this q is greater than 1 necessarily, so this is strictly less than 1. Now here's the observation over here. Since q is strictly bigger than 1, this number over here is an integer. And this q factorial will cancel every single denominator over here. So this will also be an integer, a different integer. And now I have what? Now I have two distinct integers. The difference of two integers is less than 1. So hence the difference of two distinct integers is less than 1. And that's a contradiction, because the difference between two integers the difference between two integers is, again, an integer. It can't be less than 1 in absolute value. So this proves that e is irrational. Thank you very much.